Hello, hello everyone, and welcome, welcome. Hope you're having a great day. Very glad that you're here with me today. My name is Alex Cooper. It's a little sunny outside, so I'm actually getting some light from outside. Very glad that you're here with me today. It's very sunny, like I said, so I'm see if I can move a little bit. How about that? Is a little better? All right, so welcome, welcome. Let me introduce myself. My name is Alex Cooper. I teach the computer classes for the Columbia County Library in Evans, Georgia, the Harlem Library, Uchi Creek, now Grovetown Library with our new building. Yay! Very excited about that, and very glad that you're here with me today. Now, our project we're going to be doing today is a Raspberry Pi hands-on. Okay, I'll have a handout for a lot of the stuff we'll talk about because we usually do this, of course, in person. So we actually are very hands-on with our classes and stuff. So this is a little bit different, but I actually am using this kind of to get prepared, share this information, work on these projects, and if you want to watch and follow along with me, but also things that we might use in future classes as well. Okay, so I'll start off by saying please feel free to post any questions you have into the chat. I'm happy to help in any way. Okay, what questions do you have? Have you tried some of these projects before? Kind of comment in the post there. I'll kind of go ahead. Yay, it's December. We made it to December. Yay, yay, yay. So let's talk about our classes that we have coming up for our holiday season. Okay. Of course, today we're doing our Raspberry Pi computer projects live with me. We'll do a soft light. We're going to learn how to control brightness with a LED and a potentiometer. And then we're actually, tomorrow morning on the 2nd, we're going to be doing some of our holiday STEM projects and stuff. So we have opportunities 3 times because we actually have 3 new classes. One is Holiday 3D Blender. Okay, so we're going to use the program Blender, which is a free 3D creation software, and we're going to make a snowman. Okay, so come join me with that. Of course, I'll have the instructions to install all that and everything tomorrow. Tomorrow afternoon, we'll be doing another part of our holiday coding with Python. We're going to be making a digital snowflakes. Okay, so we're actually going to be coding in Python, getting what they call the drawing turtles to move around and create digital snowflakes for us. So join us for that. And then, Thursday morning, I skipped a thing. Thursday morning, we're going to be doing gadget help with me on Facebook Live. So come join me for that on the Grovetown Facebook page. Okay, we only have 3 weeks this month because that's when Christmas happens. It's in the holidays and everything. So whatever you're celebrating, have a great time, and hopefully maybe some of our projects, maybe some of our little holiday things will bring some joy to you. And also we'll finish up again by doing some other ones as well. And on the 10th, we actually have a big important class. If you're a cable cutter, come join me for that one. We've got some information about some of the services are going up on their prices, some of the other alternatives that are on there, and of course an antenna is a good alternative as well. So come join me for that. And of course on the 16th, we're going to be doing a gadget help again on Facebook Live on the main library page's Facebook page. Okay. Now on the 15th, we're actually going to be doing another one of these, and it's actually going to be a new project called Colorful Light. So we'll be doing those projects too. All right, so come join me for those classes. It looks like it's going to be a lot of holiday fun. Drawing, creating, 3D snowman, making a scene, animating a snow scene in Blender. So come join me for that, kind of all ages. On a little side note, our RB Digital has actually switched over to Libby. So if you are looking for free audiobooks and free ebooks, all you need is your library card. Okay, install the Libby app. Don't search for Evans, don't search for Grovetown or even Harlem Library 2. When it says what's your library, say Greater Clarksville Regional Library System, and then choose Georgia download destination, and then enter your library card and you're good to go. Okay. Our libraries are open with limited services and hours. Curbside holds pickup is available. You can go to gchrl.org for details or call into the library questions Monday through Friday, 10 a.m. to 5 p.m., Don't forget to like us on Facebook and subscribe to our YouTube channel. Right now we're having a subscribe drive where if we can get 100 subscribers to our YouTube channel, we'll get our own customized YouTube address. Or you can search YouTube for GCHRL videos and our channel will pull right up. Okay, so let's go ahead and I'm going to say, and I'm also going to switch over to my other camera here. Let's see. Hold on one second. All right, so give me 1 second. Let me make sure that that is coming in like it's supposed to. Let's see. Yay, there we go. Okay. So there we should, yeah, you should see my hand now. Okay. So let's go ahead and we're going to cover a lot. So here's my project desk here, and I actually have the project we previously had set up as well. And I'll actually post this in there too. And let me go ahead and get that pulled up real quick. So basically what we're doing is we're doing a Raspberry Pi project. Let's see. And the kit is actually, so basically I purchased a kit. Let me move my microphone a little closer here. Basically I purchased a kit Okay, so if you wanted to follow along, this is actually the link for the kit, because it also includes everything else that we're going to cover as well. So let me go ahead and post our main handout, and I'll I'll walk through that a little bit. Kind of to get you started with the Raspberry Pi stuff. We did some Halloween projects with our Raspberry Pi, which is funny. We did a where you could step on one of our, no, go away. So basically the handout we're going to be using to kind of get you started. There we go. Okay, so it's loading. So basically I purchased this kit. So I have my Raspberry Pi, have my normal breadboard. Purchased this kit. It was just on Amazon. I think it was either $30 or $40, but it actually comes with a lot of projects in here. So if you know someone that is a bit of a Raspberry Pi, head trying to work on gadgets and everything like that, this is actually a great holiday gift for them, because they could actually, okay, now it's finally loaded. Okay. Actually, so everything I'm going to cover is actually comes with the box. Okay. So this is my handout here, and I'll kind of cover this a little bit, but it is there for you to view it, and I don't want us to get behind on our project at all. So basically, purchase this. This is the FNK0025 free Novi RFID starter kit, and it basically has everything that I needed in here. Of course, it does not include the Raspberry Pi, and I've just been kind of working through each project that they have, because the good part about it, it's not just a bunch of components. It also includes projects for everything that's labeled in this box. Okay, so the idea was to kind of go through this, maybe come up with some new classes for the library and stuff, and also include, learn something new, but also include some projects that we could cover and share here as well. So there's my fun box. So I'll place that away. And let's go ahead and let's talk about our Raspberry Pi a little bit. So basically it's physical computing is what we're working with. Okay. So anytime when we program our Raspberry Pi to do something, It connects up even if it's an LED light or anything like that. This is the flow light, waterfall light that we did last time. So that's actually still set up. I'm going to take that apart. And we actually have a nice, you don't have to have this. You can actually have a nice little thing that this all came in the kit. Laid on top of the the GPIO pins on there. And then it actually allows you to set those up. But do remember always, first attempt in learning is fail. Okay. And here's our little Raspberry Pi. I know my monitor's in the way right now. Basic Raspberry Pi starts at $35. So it depends on which kind of kit you get. 65, 85. Make sure that you always get a really professional power source, not just using a cell phone power source or whatever. So make sure you get a good one. I'm a big fan of the Kana kits. I've actually bought a few of these at this point. I haven't had any issues with them. So the Kana kits, I would definitely recommend those. And we're going to be using Python. We're actually going to be using Mu that actually is already installed on our Raspberry Pi OS. Okay. So here's our GPIO pins. The big thing about our GPIO pins is that, and we actually have it so it's connecting here, goes through here, and then we can see our connection right here. There basically are three types of GPIO pins. There's the 3-volt pins, 5-volt pins, there's one that's ground, and then one that's GP, general purpose pin. Now, I will tell you this does actually have more advanced listings on here, but I actually have a nice Kana kit right here, and it's going to let me be able to translate exactly what I need. And that came, which one did this came with? Well, I guess it didn't come with that project box. This actually came with the last Raspberry Pi that I purchased that came with this, so it lists all our pins and stuff. So we'll know exactly what to connect to. Okay, so the big thing, of course, is we need to make sure that we have our positive, and it always has to go back to our negative, our ground, so it actually grounds, so we can have our LED light come on, we can have our switches work. Buttons, we're going to be using something new today, which I'm excited about. As a button, you press it, it's kind of on or off. And we're also going to be using our breadboards as well. So we have our breadboard here, and this is one of the things I want to talk about before we get started. So we have our rails that go down the side of the breadboard. You may notice that it's red and blue. So if we plug something in here, then all we have to do, so all these resistors needed to be grounded. We have one wire that's on the same rail that plugs into the ground. Okay, so there's your rails, but also we have our rows that go across this way. Kind of realize I kind of call the middle the river because the two things aren't connected in any way through the river. So if we plug in something here, it'll be connected to there. So there's our little area where it's connected there to our flow. I think they just called it a LED flow. I'm trying to remember what it is, but it was like a little river going down. Anyway, plug in there, and then you plug your wire in on the opposite side, and then there you go. You're good to go. All right, so I'm going to go ahead and I'm going to open up our main project here. So the link I have included, I'll show you this real quick. And this kind of shows briefly everything that's actually included in the little kit. So if you are trying to figure out, well, what is that? So there you go right there. Okay, so we're going to go ahead. We're going to look at our tutorial here. And here's the tutorial, and it's in the link that I just gave to. Again, remember this is a learning kit. So everything is included in here. And we're actually going to be working on, we're just kind of working through our handout here. We did the blink one already. We did our push button. We did the mini light. We did the flowing water. That's it. They call it the flowing water light. And then we actually did the breathing LED. The multicolored light actually had some issues with that. I'm not really sure, but only two of the lights actually lit up. So either maybe this one was wrong or some kind of wiring was the issue. May go back to that in the future and see if we can get it to work. We did our doorbell. Buzzer worked perfectly for us. And then we actually have an important chapter we're going to kind of skim through and read over to get us ready to create our soft light project. Now, the other project that we have in the rest of the month is here. It says colorful light right here. And then hopefully next month we'll get to our photo resistor, setting up a night light. There's one that's like a thermometer set up, and then maybe you mess around with the joystick one. So I'm just kind of going through our different projects that we have. There's only 25 of those, but of course not all of these are the ones that we want to do. But let me go ahead and click our chapter 7. So let's go ahead and let's start learning together. Okay. All right. So here's another LED that I figure which project this is, but this is one that I definitely want to do in the future. It actually has, how many does it have? 1, 2, 3, 4, 5, 6, 7, 8. It's 8 by 8, and it actually allows you to set up. It's almost like a little screen that you could do. Okay, so let me see which one. I guess I have the one on the right. There's a push button. All right. Yeah, I need the pedometer. And a kit actually comes with 3. This is actually to give power to some projects. Okay. So I just need 1 today, it says. Okay. And what is this one? Oh. And there's the one that does, sorry, I was holding it too low there. This is the one this is the joystick module one, which is actually pretty neat because some of the game controllers, you don't see the insides, but this you can actually see how that works and tilts and stuff. All right, but a future project right there. Here's the Rfid Reader. Okay. And I believe I already have everything else that I need. Okay, so let's go ahead and I'm going to zoom in here and let's start reading through our chapter some. It says it's an important chapter. We have learned how to control the brightness of an LED through PWM, and PWM is not a real analog signal. In this chapter, we will learn how to read analog values via I2c module and convert these analog values into digital. Okay, meaning that means that we can actually turn this. So this is analog. Our pedometer is analog. Okay, so let's talk about what we will need. This project will use the I2c function of the I2c module to read the voltage value of the pedometer. Let's see, so we got a Raspberry Pi, we got our GPIO sections here, and I'm going to go ahead and start taking this project apart. And these were all 221s. I'll set those aside for now. We got plenty of jumper wires, as you can see. I didn't want my desk to look messy, but I did want it to look like it's a project desk. Okay. We've got our 10K resistors. And let's see. I've got a resistor code sheet, and I actually have a new magnifying glass. Yep, I sure do. Okay, so we need to make sure that that's what those are. And in the future, I actually would recommend going through these before you take them out of the bag and go ahead and labeling them so that you're not having to do this, what I'm doing right now. Okay, so see 2 black stripes. So black stripe, red, kind of brownish. Yeah, so I think that is a 10K, because that is, well, let me look at the container here. It's easier to start off with these. Okay, so let's compare that. Okay, so that's kind of a bright red. Yeah, that's exactly what that is. Okay, and what is this one? Yeah, I don't think I've used any of the 1K. Let's see. No, okay. So we're good to go. And remember, this all came with the kit from the 3 Nova, or Novi, excuse me. Okay, so let's get our wires off of here. Put in our wire area. Actually, going to take off our waterfall LED. I want to make sure that you don't bend anything for sure. Okay, so we have what we need. And let's go ahead. We have our ribbon connection and everything. And I'm actually going to go ahead and plug in the Raspberry Pi. And then I can show it on the screen after it loads. Okay. All right, this product contains only one ADC module, okay, which is that right there. It's the actual picture. There are 2 types, PCF8591, okay. In the project described in this tutorial, they function the same. Please build corresponding circuits according to the ADC module found in your kit, okay. So which one should I choose? Let me look and see. That's actually the only one that I see. That may be because it says only one module came. Okay, so basically they're leaving themselves open to whatever they ship. You know, it's either this or that, I guess. Whatever we send you. Okay, so this is the one that we have. So we need to remember that it's a 7/8. I don't think it's written on here. 7830. Yeah, it sure is. Okay. So now we know what it is. So we need to do our project based on this one right here. Okay, so circuit knowledge. We're going to have to do a little bit of reading here, and then we'll get right into our project. All right, an ADC is an electronic integrated circuit used to convert analog signals such as voltages to digital or binary form consists of ones and zeros. The range of our ADC module is 8 bits. That means that the resolution is, okay, equals 256. So that is the range is at 3 volts, okay. Will be divided equally in 256 parts. An analog value can be mapped to one digital value using the resolution of the converter. So the more bits the ADC has, the denser the partition of analog will be and the greater the precision of the resulting conversion. Okay, so there we go. It's doing its steps. So we have our analog and then we have our digital. Okay, in previous chapters they showed the waveform and then its digital component. Kind of reminds me of when they first started talking about the difference between MP3s and record albums and stuff. But of course now everything is recorded digitally, so it doesn't really matter. Okay, there is resolute, I'm not sure. Signal will be divided accordingly. DAC, the reversing process across DAC direct to analog converter. Okay, the digital I/O port, input output port, can output high levels and low levels, zeros or ones of course, but cannot output an intermediate voltage value. This is where the DAC is useful. The DAC module has a DAC output pin 8-bit accuracy, which can divide, okay, into 256 parts. For example, the digital quality is 1. The output voltage is, and we know that our Raspberry Pi has a one pin that's 3.3 volts. And when the digital quality is 128, the output voltage may be, okay, so it's doing calculations, 1.65, okay. Higher the accuracy of the DAC, the higher the accuracy of the output voltage value will be, okay. Common knowledge. Pedometer, I think I'm saying that wrong, is a resistive element with 3 terminal parts, unlike the resistors that we have used thus far in our project, which have a fixed resistance value. The resistant value of the, I want to say pedometer, but I think I'm missing some vowels in there. But anyway, can be adjusted. A pedometer is often made by a resistive substance, a wire or carbon element, and a movable contact brush. The brush moves along the resistor, the element. Okay, so it's basically showing it could be like a slide. If we wanted to, this kind of shows it a little bit better than actually showing it here. So kind of imagine that being all stretched out. Okay, kind of reminds me of the, a knob on the radio in the car. Illustrated below represents a linear sliding pedometer and its electronic symbol of the right. Between the, it must be, okay, hold on a second. We'll try to get smart here.
Potentiometer.
Potentiometer, okay. Potentiometer, okay. Now we're getting a little smarter here. Potentiometer, okay. Between the 1, the and pin and 3 will increase linearly until it reaches the highest value resistive element. Okay, so we got pins, so it's 1 and 0, both sides of the element, okay. Potentiometers, rotary potentiometers, and linear potentiometers have the same function. The only difference between the physical action between a rational rather than a sliding movement. Okay, so that's the one we're going to be using today. Next, 2 weeks from now, our project will actually be using 3, it says. Okay, so let's look and see what we got going on. Let's see, and we are, hang on. Yeah, that's the one that we have. So that's this one right here. Okay. Camera should do some autofocus, but that's the, if I can hold it still for 5 seconds. There you go. So that's the one we have right there. All right, so it's talking about the different channels it have. Here's your analog input channels. There's your ground is 9. So the bottom right is your ground, okay. Common analog input channel hardware address. Okay, it's talking about its clock, and there's your power is 16. So the top right should be power, bottom right should be ground. Okay. Okay. Integrating circuit has a 2-wire serial communication mode, which can be used to connect a microcontroller and its equipment, peripheral equipment. Devices using I2c communications must be connected to the serial data line, serial clock. Each device has a unique address which can be used as a transmitter or receiver to communicate with devices connected via the bus. Okay, so wait, that's not what we're going to do. It's this one, the 30 is what we're doing. Okay, so there we have our schematic diagram. There's our ground, okay? And then here's our actual setup. So let's go ahead and let's get started with that. And I will actually try to keep our colors the same. So for our wires, okay, so there we go. Making sure you're pushing it flat in case something does happen. Okay, so I don't know if I can just hold that sideways like that. Okay, so we need red, we need a black wire, another red, another black. Oh, we're just doing red and black, okay? No other fancy colors. So there's red, and then there's black. Okay, so just red and black. All right. And let's see, that's about 4 down. Okay. So we're doing very well. All right, now, oh, there is a green cord there. So we got a green and hold on. Oh wow, okay. So I've actually put it in, they have it in upside down. Okay, so give me a moment. And if I got my tweezers, which I should. Okay. There we go. Okay. So they actually have it upside down for the wiring. It's fine. There we go. Okay, now. All right, so we've got our green. It goes to the middle one. And then it's actually going to the AO, it says. Okay, AO. All right, our black is going to the one on the right. Whoop. The cat just came off. Okay. And that is going to, I guess, the blue rail. Yep. So the blue rail. Okay, I need a red. Red is going to the left, and then it's going to the red rail. Okay. All right, need another red. That's going to VCC, and that's going to the red. All right, now to our negative rail, blue rail. Okay, so now we know that this apparently is the ground. Okay, all right, now let's do another black. Let's connect our ground on our board. Ground to our negative rail. And we want our red with our 3 volts of power. Let's see. So the 3 volts right there. And we won't hook it up just yet. We'll just let that hang on for this minute. All right, or I'll do that ground in a minute. I mean the power in a minute. Okay, so we got our blue is going to SDA. And SDA. Blue is going to SDA down here. Which, if we look at our chart, SDA is GPIO2. Okay. All right. Now with our, we did a blue, now we need a yellow. All right, yellow SCL. So SCL is going to SCL1, which is GPIO pin 3. Okay, so now we'll go ahead and connect the power one, which is 3 volts, and then that should go to the positive. Hey, look, we've got a little LED lighting up in there, so that means it does have power. Okay, so let's go ahead, and now that we've done all our setup, okay, now let's go ahead to, let's see, labeled the I2c interface as follows. Okay, so let's go ahead and get our Raspberry Pi running. All right. So now I'm connected to it. Yay. All right. It says that we need to turn on I2c. Okay, interface as follows. So we're going to go to the terminal. We're going to type in the configuration. Let's see, choose 5, which would be interface options. Then P5 yes, and then finish, and then restart the Raspberry Pi. Okay. So let me do that. Go to our terminal. And we need to go to 5, and then we need to go to the, let's see, interface 5, say yes to P5, it's P5 I2c, and we'll say, what do you want to do? Yes. Okay, interface is enabled, and then it says we need to restart. All right, while that's doing that, let's scroll down here. Okay, so we'll do this real quick. Okay, so there's just a little software we need to install. Okay, now LSMOD. I2c. Okay, good. So that's working. No, I don't think I can make that text any bigger. Can do that. Okay. Okay, so let's go down to the next part. Next, we need to install some tools. Okay. Raspberry OS by default. Next, type command install. It is available by Raspberry. Okay, so it's already. Okay, so we'll run this and see if it's there. Okay, so we're doing well. Okay. All right, so let's install that, and then we can begin our code. Okay, so it says it's already the newest version. All right, so you can actually do, with this kit, you can do C programming, but we're actually just be do Python is what our goal is. So let's go ahead and scroll down to Python. All right, so there's our Python code, and we're actually going to be using the mu mu. Okay, so unclose that, and we're actually going to hit the Start Raspberry Programming mu to do our Python code. Give it a moment. And we need a blank slate, so I'm going to hit New. There we go. ADC device requires a custom module which needs to be installed. Ooh, okay. So let's see. So C command, go here, unzip, open unzip file, sudo python, setup. The successful installation area prompts and the following. Okay, so first we have to install that, and then we can run our software and it'll tell us that it's working, and then we can move on to our next project. Okay, so let me see. So I need the, where is, so I'm going to copy this. Okay, so 1 second. Okay. So let me see something. So FreeNovi kit, LBS. Oh, do I need to unzip this? I bet I do. Yeah. Okay, so all right. And Python, and it's TOC 03. Okay, it says oh, so maybe I need to do that one. Okay. What is that? It's a zip file too. Okay, unzip the folder. Okay, I gotta unzip this now. Sure. And we need the one that says setup. Okay. Oh, it's pulled up Thorny. Okay. So the setup. All right, I'm gonna see if I can open it in the menu. And load. Let's see, you need to go to downloads, setup. Okay. So now, it's okay. So I need to do that too. Okay. Okay, so I need to make sure that I am, okay, hold on. So I need, shoot. Okay, let's see here. I can't just say run. Let's see, open, install, sudo python setup install. It'll just open up in Thorny, I think, like it's a doc file. Okay, I didn't think so. I didn't think that would work. Okay, so and I'm under home. Let's see. Oop. have a feeling I did not do that right. Okay, let's see. So Python code ADC device require custom module which needs to be installed. Use C command to enter the folder. Let's see. Unzip the folder. We did that. Unzip the folder. CD goes into the folder and then sudo setup install. Okay. Install library. Okay, so thank you. Okay, so let's try that again. Okay. Okay, so it says installed, device, processing, commenced, finished process. Okay, good. All right. So now we can do our project. Okay, so we want to run this one, the ADC Python. Okay, so let's go back to our I'm actually going to turn my camera off right now so that y'all have a little bit more seeing going on. Okay, so we want to go to our folder. We have our downloads. And we want to go to, where is it? Code. Python code, and it's 07. Here we go. Oh, it's going to open it in the wrong one. Hold on. Oh, it did. Good. Okay, so this is our code here. And let's go ahead and talk about that. So it talks about the potentiometer value, voltage values in the terminal. Okay, so let's see if we run that, what it will do. Let's see, track back, module, no module named ADC device. Okay, wheel. Okay, make sure we're running the right thing. Okay. Downloads. Okay, we had it a minute ago. So, Pi downloads. Let's see. No. Hold on, what have I done wrong? Okay, so it's under code. Code. There we go. Python code. And then 7. Okay, then double click it. Okay. All right, use I2c module to read the voltage value of the potentiometer. Let's see, import time. Okay, so I don't know if we're ready to run this yet. Let's see. Execute the following command, observe the project result, and then learn about the code in detail. Use the command. There we go. 7 I2c. After the program is executed, adjusting the potentiometer will produce a readout display. Okay. Here's the following code. Import. Is that the same code? I2c, import time. We see import I2c, def setup. There's a defined loop. While time. This code, a custom Python module I2c devices user contains a method of utilizing I2c module in this project, though that through which the I2c module can easily and quickly be used. In the code, you need to first create an I2c device object. Okay, let's see. Okay, so it's told me to run the code, and then it's going to explain the code. That, I guess that's what that is. Okay, and then we can work on our light project. Okay, so I got to get this working so our light will work. So if I hit run, see, file name, starter kit, Python, I2c. Oh, okay. Okay. So it may be in the wrong folder. Hold on. So let me get that. Let me go back again. Okay. So it says device global. Define import time from AD device import. It's found. See value, destroy, main, program entrance, program starts, try, I do run, it says my code. Okay, so file home, downloads through starter, code Python, that, I2c line. For I2c device import, module found no module named I2c device. Okay. So let's see the other. Maybe we installed it's on the other one. Okay, so if we close that, go to downloads, code 7, I do run. Throwback most recent call listed, I2c, okay, Python code, I2c Python 9, see, import, module not found, master code Python. Okay, this is where it's located. It isn't seeking it out. Okay, so why wouldn't that be running? So when we went back up here, so there's I2c device. Thought we had installed it like we were supposed to, and it said install library. Let's see, ADC 3.0. It did show 2 things on there. Maybe I need to install the other one as well, the one that says 2 on it, because it says 2. Okay, so go back to here and hold on. Does have a O2 here. I don't know if there's a difference or not. Okay, we'll do the same thing. We'll just let it extract it. It's fine. Well, no, sure. Oh, hold on. Okay, so we will try this again with the 2. Maybe there's some of these that maybe they're looking for specific model. Oh, okay, that's not what I need to do. Okay, so we're going to right click this and we're going to say, where is it? Trash. Open in terminal. Okay, so now we're in the right folder, and then I'll type this in again and hopefully it'll work. Okay, installation package, finish processing, dependence for I2c device, install. Maybe I need to reboot. It didn't tell me to do that, but maybe the Raspberry Pi needs to reboot. We're going to try this and then we'll see. Let's go back to our Mu. Okay, we're going to reboot and see what happens. So we're going to give that just a minute. Because it's saying it's installed. Okay. I'll take just a minute. All right, so it says it's installed, process dependent, finish processing, execute this file, and then it'll give a readout. For potentiometer. So, all right, now okay. Module found error, module name not found. Okay. Huh. All right, let me look this up. Let's see if there's any solution to it. Module found error, module name. So it's supposed to have installed it. It looks like it installed it. Am I in the wrong program? Can that program not do that? I'm still new to most of this. Okay. They don't have the Python IDE here. Let's see. Wheel? And Python 3 mode. Okay. See, it doesn't say that there's an error. It's like it can't find it even though I've just installed it. Okay, import I2c device. Okay, so go back here. Successful installation without errors. Prompt is shown below. Okay, so maybe all that other stuff is telling us that there is an error. Execute the following command. Observe the project. Results learned about the code in detail. Okay. So I thought this would be a quick install. And then we could start talking about making our light, controlling our light. But if this doesn't work, then we are at a complete stop. So, let's see. Let's keep reading here. Maybe it'll tell us if there's an error. The code is custom library I2c device is used. It controls the method utilized in the I2c module. Let's see, quickly be used in this code. You need to first create a class pointer, I2c, the point of instantator object. I'm going to try that. It's given a name and create a memory in the disk. Let's say define, use the member function, detect. Let's see, module, different modules have different addresses. Therefore, according to different addresses, we need to determine what I2c module is in on the circuit. When the correct module is detected, the pointer I2c will point in the address. Okay. Okay, so let's go back to our code here. Is this trying to say that? So which one do we have? We have this one here. So it is supposed to actually be detecting, but it never starts because this never happens to import. Object pointed specific device. Okay, refer, let's see, module, derived to class. Let's see. I2c Python install setup. I2c create. System bus, faced. Derived I2c, return the reading analog input. Yeah, I know that. Okay, and then it goes into the light. Okay, so let me do a little bit of research here, see if I can find a solution for us. Maybe I need to, let's see, so we've tried the install. Maybe when it's installing it is giving an error message. So maybe that's what I need to do. Let's see, it's under downloads. And then I want it to open up in the same terminal folder just to be easier. And then so I could zoom in some because I know the text may seem a little small on here. Okay. Okay, it may have just frozen on me for some reason. No, that's moving around. Okay. Will. Okay. Window pick a font does not seem to be. Okay, in process. Okay, so let's try that again. Just made the text at the top bigger, that's all, isn't it? Okay, so. All right, so let's try to type that in again, and then maybe we'll blow it up and see what's going on. So it says sudo. Okay, see, normalizing, normal view, writing, it just given a whole bunch of how it installed. It's adding it, processing, there you go, removing, copying, removing, installed, okay, to Python 2.2.7. Okay, process dependencies, finish process dependencies. Okay, why does it say 2.7? It needs to say Python 3.7. Okay, so that's 3. I don't even know if the mu, I can switch it to 2. Would that make a difference? So it's 3. Will? Let's see, 3 scratch. See, that's 3. Install library 2.7 distro package. Dependency for I2c device 1.2 finish process dependency. Okay. 3.7 distros. Okay, so that might actually be our issue, but I'm not sure how to solve that. Let's see. Okay, let me do a search here. Okay, I found another website that's discussing setting this up. Okay, should be able to cover, let's see. I actually found the actual code that we're working on. Let's see. Airline with file. Well, not found the answer yet. Okay, it said something failed to import. Okay. Okay, well, I'm not sure why I'm getting that message. If you know the answer, maybe put it in the comments. I'm trying to get this just to run as normal. That's C code. I've gone up too far, sorry. All right, so we installed the custom module. We're still getting an error, even though we are getting these messages here at the end, install user, but it says 2 here. It doesn't say 3. It says Python 2.7. I don't know if that has an issue. I know that there's a big deal between 2 and then Python 3 as well. Processing dependence for ADC device, finished processing dependencies for, which is finished processing dependency for, there you go, processing dependencies, execute the following command, observe let's see. Use command to enter I2c directory, cdc. Use Python command to execute Python code, Python. Okay, maybe this is what I need to do. Okay, I guess maybe I can't open, maybe that's the answer. Maybe I can't open that in the MU or a normal program. Okay, so we're going to go. All right, so let's get out of here. Do code. Maybe this is a special code. Okay, so I'm telling it to open the terminal folder, and I'm going to type in okay. Sorry, not found device and address, not correct address. Python AC dot Python. Okay. Please use command I2c detect Y to check the I2c address program exit. Okay. So we had that issue before. So if I go back up to let's see. We had the to detect. I believe we did that already. Maybe that's not installed. Okay, so let's see. I2c detect minus Y. I2c, yep, same thing. I2c minus Y1. And let's see. Uh-oh. Hold on. So you take Y000 download. Okay, so oh, well, we're supposed to see. Okay, maybe I haven't done this part. Let's see. Because it said it came with the Raspberry Pi OS by default. All right, so we're just going to work our way back through here. All right, so let's do that. Okay. Oh, we did do that earlier. Reading package list done, building, reading. Okay. And then we type in the I2c detect minus Y and a 1. And I don't see anything on there. When you are using the, oh, okay, that's the wrong one. Okay, when you're using the ADC, results should look like this. Okay, so not getting anything, but it is lighting up. Maybe it's the classic, I need to go back and check my wires. Classic. But this is lit up, so okay. Oh, do I install that too? I think I did that actually. Okay, and then that's the, I don't know. I'm gonna do it again anyway. Okay, so newest version, upgraded. Okay. Maybe this isn't working right, so let's try this. Troubleshooting. LSMOD. I2c. Those numbers do not match, but I thought that maybe it was different. Okay. Let's see. Type in the command, check whether this is started. When it has been started, the following content to be shown. BMC2 refers to CPU module, different modules. Okay. So that may be wrong and that not the same, and that may be okay. Okay. See the command tools, Raspberry Pi. We did that. We don't get anything. We don't get anything from here. Let's see. So let's go back. And we need to check our wires again. Okay. So I'm going to turn the thing on. We're going to check our wires again. Yay. All right. So yep. Okay. So we have our potentiometer here. Okay, to negative, power. Let's see, there to the one there. Yep. AD. See this one here. It's going to ground. Okay. This one is the VCO. Goes to power. Let's see, the blue, which is the SOA, is going to SOA1. So that's DA1. Oh, SDA1. Okay, and then the yellow is going to the S. Oh, okay, hold on. Yeah, the third one down is going to SCL. Goes to SCL1. Goes right there. All right. Now, see the ground, which is that one right there, goes to the ground. Let's see, this grounds the whole thing. Okay. This red goes to 3.3 volts. Yep, and that's going to positive. That's what's even powering the thing. Okay, so it actually looks like our wiring is all right. Okay. All right, let's see. So looks like our wiring is okay. Let's see if we can get. Okay, we're just going to walk through the steps here. see, terminal interface, default is on. Okay, so we're just going to walk through the steps. Okay. I choose number 5. All right, and then I choose I believe it's number 5 again. Go to 5, P5, I2c, then yes, and then finish in order to restart your Raspberry. Pretty sure we did it that way. Let's see. So if I go down to the I2c, right? ARM I2c. Let's see. And then yes. Choose I5 interface options, then P5 I2c, then yes, then finish in order to restart your Raspberry Pi. Okay. I2c module will then be started. Okay. Okay, all right. So I go down to 5. I need to hit select. I think I just have to enter. I2c. It's like it has already been enabled. Is enabled. Okay, it already is enabled. Okay, so then we did this. Did this, and then we get this, but it's a little bit different. And then I typed in this, and then I don't get anything. So done, 0 upgrades, 0 new install. Okay. Then we do the I2c Y1, and I don't get any feedback. Huh. Okay, so let's see. So if we're using this is the 3. When you are using ADS, the results should look like this. Okay. Hey, there's something wrong with that one. I'm going to switch it out real quick. Because I do have 3 of them. That is, yep, it's on the same row. Let's see. actually the controller in the middle here. Okay, I'm going to try to do it one more time. So I'm looking up. Let's see, unfortunately it was not functional. Okay, so I found an article, but the guy's talking about a Raspberry Pi 4. So I'm going to see if there's another article. Let's see. Let me see something. So okay, well, I'm actually been searching Google a little bit. I have not found any help on that at all. So maybe the module we had is a little different or something. Let me see. Let's see. So it could possibly be that basically we have a software change here, and this software, I'm going to go back. I'm going to actually go back up here. I'm going to look at the beginning here. We may have something that the software has changed, and now that's actually causing an issue here, where either it's not being installed properly, or it can't read it properly, or I just don't know exactly what to do. I do know that, let's see. So if I go back here, let's just talk about the Raspberry Pi in general. Just something that I was supposed to have installed. That's the operating system that I'm using. And you see this is pretty up to date because it's calling it the Raspberry Pi OS. Yep. see. Well, I hate to end on a note of I'm not sure what to do, but I may have to. Because my plan today was we're actually going to go through this, get this set up. Thought this was important to learn. And then once we actually get our this set up, what we're going to do is then actually work on our LED, which was what my plan was. And then we could have worked on our soft light. So the plan was actually get it this project set up with our LED, but because I can't get the previous project to work, this project would not work either. And go to the Python code part here. But you had to have all that stuff set up beforehand for that, and then you could actually control the brightness of the LED. Okay, so we may actually be working on that project next time, or at least I'll give an update on it, will be my plan. So I'm going to do more research. I know we're coming to the end of class here. I'm gonna actually do more research on figuring out exactly why this didn't work. No, excuse me, not this work, but why our project didn't work. And we'll look ahead to try to get caught up on getting it installed and everything. So next time, come join me next time, and what I'll do is I'll actually do a refresher of this class and hopefully have an answer for that. So if you're looking at this on YouTube, it'll look like one video, and then if you look back through our live stuff, it'll be another video to go through. So hopefully maybe you know the answer to some of the stuff I've covered today, but hopefully you did learn a little bit here. As I said, we're just kind of going through, they're using this time as our Raspberry Pi project time, just kind of going through the different projects that are listed in our little kit here. Okay, so stay tuned with me. The good part about is that you can actually fast forward and rewind, and hopefully I'll come back and I'll post information if I do have it into the I guess in the comments of the video if I find a solution for our issue. Okay. So thank you for joining me today. I know we didn't actually finish our project or anything, which disappoints me as well, but next time I'll come back and I'll actually either do a refresher if I get this project working or what was happening, or I'll post it in the comments as well too. So definitely come to and join me about our other upcoming classes that we have coming up this month. Yay! It's of course December, so we're doing some fun stuff. We're going to be doing some Blender 3D drawing and animation as well. So come join me for that. Also need to do we're doing a Google School tomorrow, and we're also have a cable cut the cable class coming up. So we have a bunch of holiday fun projects to do with 3D and drawing and everything, and they're kind of for all ages. Okay, so I know this project's a little bit more advanced than most because this is just kind of our Raspberry Pi projects, but we will be doing this again on the 15th, and like I said, I'll give an update on our project and stuff like that. So come join me for those, and do realize that our libraries are open with limited services and hours. Curbside holds pickup is available. You can go to gchrl.org for details, or you can find our library page just by searching YouTube for GCHRL videos. Okay. All right. Thank you for joining me today. I'll see you guys next time. Like I said, I'll work on this project a little bit, and I'll do an update post in the comments, or when we do our next Raspberry Pi projects with Alex, I'll give an update and we'll have the information there. Okay. Thanks so much for being here. See you next time. Bye bye.